G'day, welcome back. I'm returning to my series on chess software, and actually I'm doing a more detailed look at scoutfish, which you've seen me use a lot in terms of searching for endgames, attacking patterns, specific moves, sacrifices, all sorts of things, right? So it's been a very useful tool, and it's super fast, and I wanted to have a look at how it manages to do that. And then secondly, the recent piece I did on Smothered Mates, I found that I was sort of getting to the limit of what I wanted to search for, and I thought it'd be useful to sort of to tweak Scoutfish and add some other search functionality to it. So I'm going to do a little bit of that as well. Right. Okay, so let's go to the capture screen. So basically this is what we're going to cover today in terms of Scoutfish. Obviously what I said, we're talking about super fast searching, search for many different things, and then the way we think about it, there's a make step, which is pretty key in terms of taking your PGN file and turning it into effectively a compressed sort of database, which can then be used by the query step, which is where the lightning fast search is happening. And I'm going to say some things about that. Okay, so that's an outline for today. Okay, on the make step, let's have a look at what the GitHub tells us about it. You start building an index out of a PGN file. So you take a PGN file in and you run this make command, which here you can see you can run it at the command line, and you can also run it in the scoutfish.py, which comes with a package which does it for you if the .scout file doesn't exist, right? So it takes .pgn, creates .scout file. We'll go through that process, and then once you've got .scout file, then you start doing your queries. So I've run that already. Just let me bring up the terminal so you can see what happens. I ran the make command and it went through 5 million games, and how many millions of moves? 436 million moves. Could handle 77,000 games per second and could handle 6 million moves per second. Now that's damn fast. Now this goes back to the way Scoutfish actually uses Stockfish's move and position information or structure, which is very fast. Doesn't use the engine, but just being able to maintain a chess position and work out the legal moves and all sorts of stuff. And Stockfish is very optimized for that. So Scoutfish just copied that. 659 megabytes per second. That's cool. And then, so the file size comes out, the database file size comes out, and you can see there that's nearly 1 gigabyte. It's 900 megabytes. And it took, you just have to do this once. It took 70 seconds to do the calculation. And what we do now, ls, you can see the two file sizes there, right? That Caser in PGN style is 4 gig, and Caser in sort of scrunched size is only 1 gig. So there's obviously a big file saving there, and that really helps a lot. But then the other thing which is important is it's actually making the moves much easier to handle. So if you look at my comment here, it's SAN versus UCI, right? So SAN is like knight to F3, right? That's first potential reopening. Whereas UCI would be F1, G3. And you can see the difference, right? That if you give the computer information like that, it knows the squares automatically. I mean, obviously still has to do a bit of calculation. It has to subtract A from that, multiply by 8, add 1, and so on, right? But actually add 0, right? And G3 is the same sort of calculation. Whereas this one, okay, it's got the moves going, it's got the square it's going to. First character could be, if it's a pawn, it could be a file. And if it's a piece, then you've got to work out what piece it is and then go and look at the board position and find out whatever, right? So in terms of calculation, what you want is a UCI style format. And that's effectively one of the things which Scoutfish does. Just going to load up. Have a look at the H include file, and here we go. Stores the move information really efficiently, right? So a move needs 16 bits to be stored. So that's like tiny. It uses 6 bits for destination square, 6 bits for the origin square, and then it uses a couple of other bits and pieces for if it's a promotion, and this helps in the searching. And then you can see en passant castling, and is it promotion? That's the piece. Casting, right? So it's really crammed the information into just one word of data, and then when it actually is doing the search, it just gets that word of data and does a few bit manipulations, a bit mask, and then a sort of a bit rotate left or right, and it has the the from square, that'll be from 0 to 63, and the to square, that'll be from 0 to 63, and then I can quickly compare that with the query, which is the second part of it that you give it, right? So this is just an amazing way to squash the data, and then by squashing it so much and in a format which is very easily machine readable, it can really do fast scanning. Now, I think the best way of looking at that is I've got hex edit up here. I'll just show you, right? There's hex edit with the actual original PGN. You can see off to the right hand side is PGN. A lot of these first games are junk games, so I'll just scroll down a little bit. And you can see here's some moves, right? That's what a PGN file looks like, and actually in hex the characters in the file look like that, right? And you can see the other thing here is you've got the game information, which to start off with, date, normal sort of stuff. This is a fill it all game. That's not including the .scout file. What the .scout file does, it has it indexed into the original PGN, so that when you do want to go back and get the PGN with all the other game data, that you can find it. But because it's not in the scout file, you can't search on these things. I mean, I like searching on player names, but you have to do that later, possibly in Python.js, after you've already filtered down to the sorts of games you want. So that's what the PGN file looks like. Get out of that. And let's have a look at what the scout file looks like. I say these first games are all junk games. And what you're basically looking for is there's a bunch of zeros, which kind of indicates the start of a game. And there's some information, which is probably the index into the PGN file, I don't know for sure, and then you start seeing the moves 1C03. Seems to be a very common pattern here. 1C03, 1C03. You can see I'm assuming all these things, all these moves, they're the moves, and then you get to another. That seemed like a long game. You get to another block of zeros, some index information, and the moves will start again, right? Obviously, the way it's been compressed into the word, you don't quite know what numbers come out. But what happens is that the file size is tinier, and the information is recorded in a very good way for the computer to go through it very, very quickly. Right. So basically, what's happened here is they're just sort of doing these things. The moves are mushed into a smaller space, and they're recorded in a form which the computer can instantly sort of, if you're searching for knight f3, it'll be searching for. The games are shorter as well because they haven't included the header information and so on. So the file size, you saw there, about a fifth or quarter or fifth of the size. But mind you, when we did that, we saw the moves per second, 6 million moves per second, which sounds like a lot, but you ain't seen nothing yet. So now we move on to how it does the query step. Now, as I said, this was just a command line argument. You can do make, and you can do the same thing. Well, I've closed. You can do the same thing and do the scout from the command line. Okay. Now let's not do that, but it should be easier to look at it in the Python script. Easy to understand. Obviously, they've got this little wrapper down here, which I've sort of done a lot of stuff to. So if we look at that, basically, I've got we import it, you run it. Set the number of threads. Just make threads 1, just to database, and it'll because it's using the Python imported function, it'll check for the .scout file, won't create it, and I've just tried to create this quick query on material balance and positioning of the rooks and so on. I'll return the full information that it gives us, just so you get a sense of what Python.js returns. Okay, so this is actually what it gives back to you, right? Number of moves, number of games it found, moves per second. Now look at this number, 28 million. What was the number we had before? About 7 million, 6 or 7 million, right? So way faster now, and that's only using one thread. So let's see what else we can do. Took 16 seconds, fine. And this is the way it returns information. Basically, you offset in the file, right? And then if you want to go and get the file, then you open up PGN, and this is quite a simple way of doing it within the Python wrapper he's given you. So that's using one thread. Let's amp it up to 10 threads. Well, came back almost instantly. And what's it done there? 254 million moves per second. Now, that just gives you the how fast this can be. It can basically search the database within a second. And I've done a bit of testing, we do testing on things. If you go past the number of cores you have, it slows down quite a bit. Now, there's a lot going on here. I was going to do nice little diagrams, but I'll just try and explain it in the simplest term possible, right? So you can see the move per second. You can get up to 300 million moves per second, and there's only like 400 million moves in the whole database, right? And so it's using a couple of really clever tricks here. First one is memory mapping, right? That file is large enough to be mapped into memory, right? So when you open the file, you memory map it. So it doesn't actually open the file, it just says allocates a space to it, and then it'll be, in terms of the way Linux works, is that there'll be sort of blocks in the page table that are marked as they're not there, and then the first time you want to use the data, then it'll load it in block sizes. I think it's typically 4K. So the kernels will handle that for you. And then, so because you're doing that, and because the file is in a very neat fashion, what actually Scoutfish does is it splits up the task across the file, puts pointers, like 10, divides in 10 even sections, and then each of those 10 processes will start processing straight away. They'll load up the first block, they'll keep on processing that for a little while, load up the second block, and so on. Obviously, you want to be doing this on SSD, and it's really a classic or perfect example of parallel processing, giving you almost the full benefit. And then obviously the only slight problem is when you find files, you have to have sort of a sort of thread safe mechanism of saving the results so you don't lose them. Anyway, so that's what happens, and that's the query step. Now, as I said, when I was doing the smothered mate analysis, I was trying to do filters in Scoutfish, so that then when I look at it in more detail in Python chess is very slow. I mean, I love Python chess, but it's slow in comparison. You don't want to throw more than a couple thousand games at it. So, and I couldn't quite get the filtering which I wanted. I'll show you, for instance, in that's why I've got Skid open. Let's open up Caser, I guess. Now, this Caser database says like 4. You might find that Caser or ChessBase or chess or chess.com, they should be using some similar optimization in their internal database format to get that sort of speed. We can do a search here, moves, and let's go knight f7 checkmate. Right, this is what I really wanted to search for. I couldn't work out how to do it in Scoutfish, probably because I'm a bit stupid. So the mate sign there, and you check for checkmate, and you do a search. Right, so this is take a little while. This is the sort of search which I would like to be able to do in Scoutfish, right? Basically, search for not just a move, but also saying it is checkmate, or check. But anyway, I'll leave that running. Actually, I'll stop it. Take it too long. And it's found some. Yeah, we can go and have a look at the games list already. Well, you can see there it is. There is a checkmate, and that would have probably been one of the ones which my filter had picked up, right? Because what I wanted to do now is let's make our own search within Scoutfish. So let's load up the files I've modified. There are a couple of things you have to do. First of all, you have to modify the query code so that it can say, mate move. And then what I did with mate move is that I basically copied the code for white move and black move. Just save a series of moves, because it would be more one move, save a series of moves which have to be mate. And then you have to add the condition field and add the rule processing. So let's quickly go through that. So I'm in the source directory here. Okay, there it is in scout.cpp. Right, so this is as it's going through basically the dictionary you provided the query. You can see imbalance, you can see material, and you can see white move. White move, it just passes the moves and adds the moves to a condition. So it stores this condition, which has all the conditions in it. It stores it in a special variable, which would have the move. See, move to squares, right? Okay, so I did exactly the same thing, but I made a second list of moves called mate moves. Add that to the condition, so that after you have processed the query, you'll have a list of mate moves, and then so I've added it to the condition, and then here's the rule. So what is a mate move? First of all, it has to be a move, and the next move has to be null, basically, right? Yeah. So if the next move is not null, we forget it, right? We're basically saying hey, it's only if it's the last move of the game. Basically what I'm saying, if it's the last move of the game, then I do the check to see if that move is the one that's played. And if it is, great. And I just set a flag, has mate move equal true, so that when you come back one move later and it is the end of the game, it just checks if you've had mate move. Secondly, it's got to be no legal moves, which means it's checkmate. And the person has to be in check. Right, could be stalemate as well, right? So that's how you do it, right? And then basically when I've done that, now we have a look at that, I can go, let me just open up this file again, and change this to equals mate move. Remember, this is just a standard dictionary in knight F7 checkmate. Which doesn't checkmate. Okay, it happened 1,360 times, right? So if you do all the different combinations, and then actually if you put some simple restrictions on having rooks next to the king and all this sort of stuff, you filter it down very, very fast. And you can see it came back in basically 1 second. So that's I'm going to have a bit of fun with that. So in fact, that's actually what I was thinking of doing. So let's look at some other possibilities. So I was thinking about how often does... I get unusual results, by the way. Let's say, how often is h6 checkmate? And this is not doing quite what I want. Bear with me, let's just do the following. Get that out, get the games, and have a look. Okay, good. So that's done exactly what I want, right? And then now we can load up test.pgn. Let's have a look. Search, filter the last move. Right, so this is the funny thing. I was actually hoping to find white moves, but I didn't classify white moves, right? So look at this position. Black has played h6 and it is checkmate. I found that very funny. In fact, you can have a look at here. Here's a white one. White played g6, checkmate. That's nice. The knight holding the bishop. And the pawn's coming that square. Bishop's coming that square. So now that I've got the mate move functionality, I can sort of look at these different possibilities. In fact, the other one we were looking at was, let's try, what about knight h6? Let's see what happens if we put knight h6. Knight h7. Let's see if knight h7 is checkmate ever. Got a few, 247 games. We've got to close it and reopen it. Cochrane Staunton, search, filter last move. Okay, that's nice. And then we also look for any 0-1s there. Yeah, let's happen. What's going on here? How's that possible? It's just crazy. It's almost like a helpmate, I guess. I don't know. A bit weird. So that's black playing knight h7 mate. Okay, good. So look, just wanted to do, that's probably the geekiest of the videos I've done so far, but just wanted to explain this tool which we've been using. And I've been trying to explain, you develop nice tools for yourself that you then use for finding positions to study, certain patterns. As I said, I've used it a lot in endgame analysis as well. And now, you know, as I've got more familiar with Scoutfish, I've added this mate move functionality to it and showed you how that worked. Okay, thanks a lot if you made it this far on this video. Hope you enjoyed it, and see you next time.